Alright, hi class. So we meet again in this video. We are going to continue with your internal combustion topic, which is now it's about your diesel engine, right? So in diesel engine, it is also known as compression ignition cycle, meaning that the combustion will start with this ignition. Later we will see the videos in YouTube, right? So you are going to have this PV plot right here. So you will see that this is again your bottom dead center, this is your top dead center, and you can see now that in diesel engine your heat addition or your combustion process is happening at constant pressure. Okay, and you have another term which is your cut-off ratio, which is in between volume 3 and volume 2. So let's have a look at the video first, right? So this is the anatomy of your piston cylinder for diesel engine. So you see you have a fuel injector here and the injector nozzle down here. So this is your top dead center, and this uh, dotted line here is your bottom dead center. Okay, so let's play this video. So this is where the intake strokes is happening, right? So you will see this intake valve, and this is the exhaust valve. So during the intake, right, your piston will move toward downwards, and it will let the air comes into your piston cylinder, and this valve here is going to be open until it reach this bottom dead center down here. And simultaneously you will see that this valve is going to be closed. Okay, so at this phase your piston cylinder is actually at your bottom dead center here. So this is going to start with your state 1, and then later on we are going to have this compression. So let's have a look at here. Alright, so this is where your compression starts to begin. Okay, so during your compression, right, this is your compression process until it reach your top dead center. Okay, so this is where your air is being compressed. This is only air. Unlike your Otto cycle, inside here you have a mixture of air and fuel, which is already vaporized, right? But this one you only have air inside your piston cylinder, so it's being compressed. Right, so straight away now you see the fuel injector release your fuel, right? Your diesel fuel. Okay, so this is the state right now. So you stop at the top dead center, right? And it will hold constant at this pressure, and while this fuel is being while the fuel is being sprayed. So you will see that this is your Q in where combustion is happening. So I will play this video again. So now you have your power stroke, right? Where yeah, you can see that this is the mixture of air and your fuel, right? So it's being vaporized here, and then yeah, so the combustion starts to ignite. That's why it is called as your diesel cycle is also known as compression ignition, right? Because while the compression is happening, right, at this constant pressure, holds at constant pressure, so the molecule starts to vaporize, with a molecule of air, and your diesel starts to vaporize, and then it will trigger the combustions to happen, right? So the combustion will happen at constant pressure over here, while your volume starts to expand. So you see the expansions of volume here. So when it translates into your PV diagram, so you will see while the combustion is happening, you can see that the volume starts to increase back, right? The volume starts to increase back. So your piston cylinder is pushed downwards. So let's have a look at this animation with this your PV diagram on in here. Alright, now this is the exhaust phase, right? So you have the product of the combustions being pushed out from your piston cylinder, and this is happening at constant volume. So you will see here the valve starts to open, and this one will stop at the bottom dead center, so it will release the exhaust gas here. Therefore, we analyze your Q out here as a constant volume heat out, and your Q in here is constant pressure. So let's play again the video here, right? So you start to have a power stroke here. Okay, fuel is being injected at this point, right? And it's your air molecule and your fuel molecule starts to vaporize and mix together, and then it will ignite the combustions. And as you can see, the spring effect is still on, therefore your volume will expand until this stop, right? So you will see that the moment it stops spraying, so this is where your fuel and air is already fully combusted, and it starts to expand here, right? So therefore we need to find out what will be the cut-off ratio in between volume 3 and volume 2. So the cut-off ratio is represents with this beta, right? V3 over your V2. So where do we use this diesel engine, right? Diesel engine is suitable for large amount of powers, vehicles such as buses, lorry, trucks, or your 4x4. Because why? It has a higher thermal efficiency. Due to this density of the fuel, so it is much more energy being conserved inside your fuel as compared to your Otto cycle, right? That's why it needs a high compression. Uh, that's why it needs a high compression ratios in order for uh, the mixture to auto ignite and starts the combustion. So we will going to see how are we going to solve the problem for diesel cycle in the next video. I'm going to show you one example. Right, thank you.